Good morning, everyone. My name is Founder Liu from Imperial College London. It is a great honor for me to present our work using the big data to manage the deep learning working flow. And the work originally named TensorDB, now we changed it to TensorLab. I'm very sorry for not being to be in Las Vegas to present our work, and this is due to the visa issue. We are the Data Science Institute. Basically, we are the data manager and the infrastructure builder to support the research of different departments of Imperial College London. Typical research including the TransSmart project for clinical medicine research, the optical MIS applying big data for pharmacovigilance application, and also the Smart Heart project for big data project for analyze the cardiac MRI. My talk is organized like this. First, I will talk about the motivation and the insights behind the TensorLab system. Second, I will give details of the implementation of the data storage and the APP architecture of the TensorLab system. And at last, we will discuss some application and our future map of TensorLab system. The motivation of the TensorLab is really make the deep learning available for all the domain experts who may have little or not much deep learning experience. Dong Hao, a PhD from our group, built the tensor layer system, which really reduces the technical complexity to building the deep learning system. However, we found the data management still is a big challenge. For a non-data science expert, there are many challenges. The first is data management. So usually the data are multimodal and with multiple labels, and finding the right data for training is a first challenge. The second usually is the data loading. So usually the data size is too large to fit into memory or even hard drive. The third is usually in our research, we will build like hundreds or even thousands mode. Find the right version and the right mode is become another challenge. So the TensorLab system really try to building something like a fully autonomous system to streamline the whole process of training, evaluation, and deployment. Another challenge for us is like usually sometimes on our cluster we will train like 30 or 20 mode. There is no existing tools can monitoring the training process. And this has become typical in many of our research. So many database applications nowadays requires analysis functionality. So they have the problem of where to put the analysis results. And many machine learning systems will require the data management functionality. So our solution is putting the data, the label, and the machine learning together into one data warehouse. So this become the TensorLab system. However, if we consider real application, the data, the label, the machine learning mode, everything is changing. So this become very chaotic. So in the TensorLab system, we build a search engine on top of the heterogeneous data warehouse, and all the APP connected talk to the search engine and building different jobs. And all the job will be stored in the job queue and then distributed to different computing nodes. So this is basically the architecture of the TensorLab system. It is built based on three principles. The first is everything is data. We store the training data, the machine learning mode architecture, also the parameters, the training log. Everything is stored in the data warehouse. The second is all the application will query, it will find the data by the database query. This enables us to make the software architecture very flexible. The third is we build a pooling-based streaming processing pipeline. So the data is only loaded to the computing node when it's needed by the training. For the data storage, we use two-layer storage. The top storage is a non-circle document DB for index. Each document is a key value pair. The second layer storage is like a blob storage system, such as a file system, and all the search is by the map reduce performed on the index. The software is a multiple layered. The lower layer is mainly the 3 data warehouse, and then unified interface by the TensorLayer database interface. And on the lower API layer, we have a data ingester, data streamer, a model logger, and a data render for visualization. On the high-level interface, we have something like we have a high-level script can specify training, evaluation, and different kind of jobs. So if we look at the code, on the lower level API is very simple compared with traditional deep learning code. You just specify your database, you find your training data, you find the parameter, finding the model architecture, and then training your mode. This is the low level API. On high level API, this is more like putting a dictionary, and you can build a command line interface like the following part. Typical application is for observable tumor segmentation. So for this task, we have 4 imaging modality, including T1, T2, T1 compressed, and T2 flare MR data. So for each image, we will segment both the high and the low grade. And there are 4 types of tumor, and want to cross-validation. So together, we have to training something like 100 modes for different imaging modality for different tumor type. And for the TensorLab system, we just need to build one code and slightly changing the parameter. This make our lives much more easier. Another application is in the TensorLab system. You can update your training data set even in the training process. This is very valuable for in the industry because as the machine learning system goes, new training data will be added. And it is also very valuable for the reinforcement learning. So you can see on the code, we can input your new data and also put a time tag. Under the data generator, you just specify to get the latest training data. So you don't need to change your code. You don't need to stop or restart your training. Everything will be automatically updated. The first implementation of a TensorLab system is based on MongoDB, with a MongoDB cluster as a storage system and tested with up to 32 GPU node as a computing node at the Data Science Institute. We are now working on the 0.50 version, which we try to make it working on public cloud. Now, we have experimental support for the Google Cloud platform. We hope that the final ready release will support all the major cloud providers. And for the 0.20 version, we are expected to support hybrid cloud or cloud support. This means you can put part of your data locally, part of your data on a cloud, or across different cloud providers. And thank you very much for listening to my presentation. The TensorLab system is going to be released open source with the TensorLayer library. alpha version, in fact, is already released. We are just currently working on the documentation. Following is on the screen is the website for the tensor layer. And for more questions, please email me. And I'm very sorry for not being in Las Vegas to present in person today. Thank you very much.